Yes, this is the video solution for problem number 2 of the midterm in lab section 51. As you can see, problem number 2 here is a beam problem. Uh, the most appropriate element is beam. Do not use solid elements to do this thing. Okay, we already have trained our eyes to see what is a beam, what is a shell, and what is a solid. This is a beam problem. You must be using beams. Now, the coordinates are given here, and also the loading is like this, like a moment about the y-axis, as you can see. So you're asked to use all planes of symmetry. These top ends are clamped. So if you look at the moment, you look at the geometry, you know that there is a plane of symmetry. XZ is a plane of symmetry. So all you need to do is to model half of this, okay? And then clamp and then apply the appropriate load here, which incidentally, if you model half of this load must be half of 100. So it'll be 50 pound-inch, okay? So because these are, these are in different, these are not in the same plane, this line and that is not in the same plane, that arc is not in the same plane. I'm going to be using wireframe. In other words, create 3 points here, E, D, and C. I'm going to create E, D, and C, and then connect this thing with a line and connect this thing with an arc of a circle. Okay, good. So let's go ahead and do that. Uh, okay, so let's start with the part, and I'm solving this thing as a part problem. It can also be done as an assembly, but I don't know why you would do that. Okay, immediately we save it. So file, save management, save as, desktop, new folder, and I'm going to call this thing midterm, lab 52, lab 51, and it's going to be problem 2, which is incidentally is B. Okay, let's put that part in there. And immediately I'm going to create 3 points in space with the coordinates, the 3 points D, E, D, and C, for example. I can also use A, B, and C. That's up to you. So let's start with this. So you look at that, it's going to be 0 minus, it's going to be coordinate of E is going to be 0, 0, 10, and 20. 0, 10, and 20. 0, 10, and 20. Okay. Then another one that's going to be uh, coordinates of D, and the coordinate of D is 20, 10, and 0. 20, 10, and 0. Okay. And finally, the coordinates of C is going to be 30, 0, 0. So 30, 0, and 0. Okay. We are done. Cancel that. We are done with our 3 points. Uh, I have a suggestion because I know what the center of that arc is, center of that circle is. The coordinate of the center of that circle is, if I'm not mistaken, 20, 20, 0, 0. So let's create that. One more point, 20, 0, 0, because I'm going to use my circle. Okay, yeah, very good. Okay, now a line, create a line between this point and that point. Say okay. And now I want to create a circle. Well, the different ways of having created a circle, you could have used 3 points if you had 3 points of it. See that? If you, for example, have B, C, and D, you could have done it. or you can use the center and a point, etc. So let's go ahead and do it with the center and a point. So let's see, that was the purpose of that last point. Now, if you want to draw a circle here as a wireframe, you cannot do it in part design. Okay, you have to go to generative shape design, which is right here, and there is a circle. Let's go get the circle here. It's not there. Gotta find out. There it is. Okay, and let me rule this out. And the different ways of making a circle. The methods is going to be determined by you. Center and radius. I can, for example, say I can say center is this point and radius is 10. Okay, so that's one way of doing it. The center is here and radius is 10. Okay, and uh, and the support and the support. Okay, so let me get through this. Move this thing out of the way. Okay, and let me see now. The support is the XY plane, correct? XY plane. You just have to be careful about this angle. You want to go between 0 and 90, something 90 degree. So let's try 0 and 90 here. Let's see how it works. Yeah, that looks good. It's right there. Okay. There we are. Okay. Very good. Now, because what I would like to do later on, because these two have different cross-sectional areas, the way I described it in class, the way I did problems for you in the class, I joined these, applied the same cross-section on both of them, and then used a 1D local property, something like that. Okay? So first of all, let's join it. There's a join. There are different ways of doing the problem. I'm not suggesting that you do it this way. As long as you get it to work, that's fine. So there is a joining of these two, okay? And apply material. This is all made out of steel, I believe. So metal, move this thing out of the way. Metal, and it's made out of steel. On that part, we say okay. All right. Let's save it. Notice that this center point that I created is never going to be used again, okay? Now, we're going to go to generative structure analysis. Okay, and we are going to mesh this. Because we joined it, we can do it right at the same time. So you click on the beam element, you select that. Because we joined it, they're both going to be done simultaneously. Let's put down some number here. 0.5 is good, because remember these things were, the radius was 10 inches. So when you think about it, yeah, that's fine. We don't care about the actual size. Now we put a 1D property on this. Okay, on the entire join, we're going to make it circular cylindrical beam, and with the radius, let's take the bigger radius, and then we're going to change the one for the circle to the smaller one. So the bigger radius is radius 0.75. Okay, you can see that right there. It's a circle right there, 0.75. And because we have the opportunity to go and refine it, right click. See that you put the cursor on local 1D property, local 1D property, select it, and then you select this guy and say, oh, the radius here I want it to be different, and that radius is 0.5. What happened? Last time I used this, I used 0.15. I don't want it. I want 0.5. Say okay, and that's it. We say the support is right here, and we say okay. Notice that what happens at the ends of this arc, circular arc, you have a smaller radius. Okay, we change this 0.75 to 0.5 basically. That's what we did. All right, this is it. So when we save our analysis, file, save management. This is the analysis, save as. Right folder, yep, beam. So we just put the default name there. Okay. Good. Let's see. This top point is clamped. So you say clamp. Do not put it on the point. That's no good. CATIA will take it, but when you run it, it's going to not see it. So hide this point, either from the tree or from the screen, and just select the vertex. You see that? Vertex. Okay. Now, this one, let me hide the stuff that we don't want to see. Let me hide that. And also, I'm going to hide this point. Again, I don't want to put the stuff on that point. Hide it again. So this point is in the plane of symmetry XZ. So XZ plane of symmetry, you select it. You select this corner point, this vertex. It is in the XZ plane of symmetry, so it does not move in the Y direction. That's direction 2 of the global. And its rotations are opposite. Very good. Okay, now we are also applying a moment about the y-axis. Moment about, yeah, modes of 50, half of 100, the moment of 100, and then we're going to save it and run it. Let's look at our deformation right here, viewed from the side. Okay, let me change the scale here to default. Okay, you can see that. And if you apply a moment in that fashion at that location, it's going to move, looks moving down. You can see that. And if you want to see actual numbers, plot the displacement, double click, and colorful, average ISO, and there we are. So this is the view from the side. The displacements are here, given to you, and you can change the view from some other direction, for example, the isometric view. There we are. Okay, and that wraps up the problem 2 for lab section 51. Now, remember, what some people may decide to do this thing when not joining these. Not that's perfectly okay. But if you're not joining these, you have to mesh these separately. Number one, and you have to assign properties separately. And then at the juncture, you have to create a connection between the end of this bar and the end of the circle and make that connection rigid. Okay. You can do it like that, and if you do it properly, you will get the full mark. Or if you did it up to a point, everything was done, you get part marks. But the way I did it in class was this kind of a thing. Okay, good luck.